Hello everyone. My name is Vikram and today is the first lecture of basic mathematics intended for class 11 students. दो ये दोनों किस्म के स्टूडेंट्स के लिए applicable है like whether you are a biology stream student or a mathematics stream student, but it is prepared keeping in mind the mathematics student basically. But let's see what happens, whether you like it or not. सारा कुछ अवेलेबल है वेबसाइट पर। वो जो दो वेबसाइट मैंने बनाई हैं, आप किसी भी एक वेबसाइट पर आप जाएंगे या तो grandmaster.in पर जाएंगे तो you can find the relevant information there, or you can directly go to the GMPB, Grandmasters Physics Blog, GMPB, GMPB.in, both are .in websites. So I'm going to talk about basic mathematics and trigonometry first. So I have started it from the right angle triangle. You can say right angle square. Here it is. And you know this is the right angle. Call it 90 degree or pi by 2 radian because you know pi radian is equal to 180 degree. This is the basic relation between degree and radian. Sometimes लोग आपसे क्वेश्चंस इस पर भी पूछते हैं कि आप डिग्री रेडियन इन सब के बारे में जानते हैं कि नहीं, अगर आपको तो पता ही नहीं है if you don't know, this is clear that this is pi radian equals 52 degree and we are talking about right angles, right triangles. That means it will have a right angle and that right angle you can write pi by 2 radian. 90 degrees, whatever it is. And I have to consult the lecture notes sometime to provide what I'm going to give you the information. So my lecture notes suggest that by convention, trigonometry में भी कुछ convention होते हैं, तो convention के हिसाब से ये जो side length है, इसके जो तीन कॉर्नर्स हैं ए बी एंड सी, कॉर्नर ए के सामने वाले साइड लेंथ को आप सिंपली स्मॉल ए लिख सकते हैं, कॉर्नर बी के सामने वाले साइड लेंथ को स्मॉल बी या एंड कॉर्नर सी वाले के सामने को स्मॉल सी लिख सकते हैं. दैट मींस यू आर व्हाट आर यू डूइंग दैट you are simply writing the side length BC equal to AC equals B and AB equals C. See, in the same manner, again a convention. You can write the angles simply as angle A, angle B, angle C, or you can write angle A as angle A equals CAB. That's true. Like you can write like this. And in the similar manner, you can write angle B equals CBA, angle CBA. And angle C, that is right angle triangle, you can write it like angle ACB, like this. So these are the conventions. And you know basically that there are 6 trigonometrical ratios. As a class 10 pass student, you must have known this. आपको पता ही है, सब लोग जानते हैं, क्लास 10 के जितने भी स्टूडेंट्स होते हैं सबको पता होता है कि there are 6 trigonometrical ratios. Sometimes we call it trigonometric functions. Like the 6 trigonometrical ratios are sine, tangent, and secant are basic 3 trigonometric ratios, and there are three co-functions or co-ratios. Cosine, simply written as cos, cotangent, that is a co-function of tangent, and cosecant, sometimes written as CSC or cosec, like this. So, you all know, obviously, you all know few things that we simply write sine theta, for example, and writing here sine A, taking this angle. If you take this angle under consideration, then sine A will be written as perpendicular by hypotenuse, that is A by C in this case. So you can write A equals C sine A like this. Or you can write here cos A base upon, since we are considering this angle, so our cos A becomes B by C in this case. And tan A is perpendicular by base, that is A by B. And so tan A can be written as sine A upon cos A. And you know that cosec A is the reciprocal of sine A, sec A is the reciprocal of cos A, cot A is the reciprocal of tan A. So, nothing more to discuss here. And since we are talking right angle triangles, so I wanted to use one very much popular property of right angle triangles, that comes from Pythagoras theorem. And that is base square plus perpendicular square equals hypotenuse square. So, in this case, base and perpendicular are most obvious. They are A and B, so you can write here simply this triangle. You can write here A square, B square is equal to C square. If you take this angle A, then A will be the perpendicular, B is the base, and C is the hypotenuse. So you can write here A square plus B square equals C square. And you can also write A square upon C square plus B square upon C square equal to 1. You know, A by C here is sine A by C, A upon C here is sine A. So, A square upon C square can be written as sine square A, and in similar manner, B upon C is cos A, B square hypotenuse. So, B square upon C square can be written as cos square A. And you got a formula in terms of sine and cosine. It is sine square theta plus cos square theta equals 1. I think this is a very popular formula. You can divide it by sine square, both sides by sine square. If you divide this formula by sine square, both sides by sine square, then you can write here 1 plus cos square A by sine square. Cos by tan by sine is sine by cos is tan A, sine A by cos A is tan A. So cos A by sine A will be obviously cot A. So you can write here 1 plus cot square A equals cosec square A. 1 by sine square A is cosec square A. So there is one more formula for you. You can divide the both sides of this equation by cos square A as well, and you will get here tan square A plus 1 equals 1 upon cos square is sec square. So this is your third formula, tan square A plus 1 equals sec square A, or you can write here tan sec square A minus tan square A equal to 1. Whatever you want to write, the formula will come through this right angle triangle. Just exploiting this right angle triangle will give us 3 formulas. You can see what you are studying. These are the basic things I know. Tell me, just don't talk like this, but I would like to go with this. And again, you can do something else like you can take a right angle triangle again. Let me draw one. Oh no, let's draw a right angle triangle. This is perhaps right angle triangle. Not by your standards, but from my standard, it is okay. So here is the right angle. If you like to write, this side can be written as E, simply this side by C, same side simply by B. And if we assume some interesting situations like make it isosceles triangle and take this angle as 45 degree or pi by 4 radian. This angle is again 45 degree. So this side, this BC and LB will be equal. That means A is going to be equal to B. And then you can find, then you can use your Pythagoras theorem again, and you will find something like A square plus B square equal to C square. Again, A square plus B square equals C square. Using Pythagoras theorem, since A is equal to B, so you can write here C square equal to 2A square. That means you are going to write 1 by 2 equals A square upon C square. That means you can write here A square upon C square equals 1 by 2. And A by C, you can guess here, A by C is cos 45. And from this, if you take this 45 degree, so both the angles are 45 degree. So if you take this thing, this angle, this one, then this becomes the base, and this is your hypotenuse. That means you get your cos 45 degree, cos square 45 degree. Oh, not like this. Oh, sorry. You can write cos square 45 degree is equal to 1 by 2. And if you take this angle, then this becomes this 45 degree, this one. That means it becomes your perpendicular, and this is hypotenuse. So perpendicular by hypotenuse is sine theta. So you can write A by C as sine square 45 degree. That is also equal to 1 by 2. That means cos 45 degree is cos 45 degree and sine 45 degree have zero values. And both will be equal to 1 upon root 2. And that means tan 45 degree or cot 45 degree will become 1. So you can find values by using the Pythagoras theorem. What about other things? You can do other things as well. You can also find 0 degree and 90 degrees by just degenerating this triangle. Or you can assume this angle is equal to 0 degree. Make 145 equal to 0. And you will get your values. And how will you find the 90 degree? This is also obvious. I'll show you. Let me do one more thing here. You can get 30 degree and 60 degree as well. So draw a right angle triangle again. Look, this is your right angle triangle. Of course, A, B corners are ABC. This side length is A, this side length is B, this side length is C. Here is your right angle triangle. Now reflect this point A across this length BC. What I am doing that I am trying to make an error image of point A across the line BC. Line BC के cross अगर बना दिया, name it, let's name it D. So, this is not good enough because I have drawn it miserably. Here, what I did, I would like to make it clear. AC is equal to basically CD. I think this angle is 60 degree. This is going to be 60 degree as well because B is the mirror image of point A. And this is sorry 90 degrees. So if this is 60 degree, this is going to be 30 degree. Both angles are congruent. This is also 90 degree. This so it will also become 60 degree. So you can see here you got you first had a right angle triangle, then now you have an equilateral triangle. Both sides are 60 degree, sorry, all angles are 60 degree. That means you can write here AB equals CD equals AD, all sides are equal. Also, you can see here AC is equal to CD is equal to AB upon 2 or AD upon 2, AD upon 2. This will be right thing to write here. AC equals AD upon 2. But since AD is also equal to AB, so we could have written it as AB by 2 and nothing was wrong. So AC you can see here is AD by 2, that is AB by 2. And then what can we do? We can do one thing, we use the Pythagoras theorem. That means I can write here C square equal to AC square less A square. AC square plus A square. And AC is AB by 2. AC is AB by 2 or of course AD by 2 or AB by 2. I will choose AB over AD because oh sorry, this length AB is equal to C and I have written AB square. Oh, so sorry, I can't write it again. Here AB square equals AC square BC plus BC square. AC square plus BC square. And AC square plus BC square equals AB square. That means C square equals AC. AC is equal to AB by 2 or AD by 2. So I can write here, I will choose AB over AC because it serves my purpose. So AC equals C by 2. That means I know C square by 4 minus plus BC square. BC I would like to be BC. Though BC is given A, but we can also write BC equals A, no problem. That's A square. That means if we take this C square by 4 to the left side, we will get 3 by 4 C square equals A square. Did you get here? A square upon C square. You get here simply as A square by C square equals 3 by 4. And since A and C both are sides So their length will be positive, of course. So you can write one more thing here, that AC, A upon C will be equal to root 3 by 2. We put square roots both sides. And what is your A upon C? It is A upon C. This side length is A and this is C. So A upon C is basically, in terms of 60 degree, you can write here, this becomes sine 60 degree, A upon C. A upon C is sine 60 degree. That means you can write here sine 60 degree equals root 3 by 2. And you can also say, if you take this 30 degree here, this becomes the base. So A by C is cos 30 degree. So sine 60 degree is also equal to cos 30 degree. And you can also find other things like sine 30 from this figure. Sine 30 is AC upon, you can say here. No, you can see. Yeah, it is visible right now. So you can write here sine 30 degree equals this length perpendicular, that is AC, and AC is C by 2. By hypotenuse equals 1 by 2. And if sine 30 degree has this value, that means cos 60 degree. Cos 60 degree will have base again, that is equal to C by 2 and hypotenuse C. So sine 30 degree will be equal to cos 60 degree. And it will also become 1 by 2. So you can make your table. You know, sine 0 degree is 0 and cos 0 is 1. And later you will also be able to find sine 90, cos 90, other like this as well. So these are the things we have gone so far. Now, if you like to use the right angle triangle again, you can do one more thing. Yeah, I think it will be right to do, the right thing to do. Let me introduce you to some angle called some angle, or something like this. Some angle, yes, some angle. So, some angle, product, some angle. Yeah. So compound angle, and they call it compound angle. Oh, okay, I was looking for the name. Let's draw a right angle. Right angle here. So yeah, make it perpendicular like this. And this is an exercise basically. I'm trying to provide you an exercise. I forgot what I'm doing because I'm some kind of a stress here. And what is given that this side length AB side length is given here. Given AB equals x and this angle is theta, angle A is simply theta. And you need to find every other thing that is not given here. You can find here AD, BD or DB. AD equals what, you can find DB equals what. CB, the length of CB, and then of AC. You need to find everything else. This is, I left you as an exercise. If you want to do it, you can do this. And now that you know many things, you need to do one more thing. And somebody written to me that y is not sine alpha plus beta is y not sine alpha plus sine beta. Can you prove it? And also wrote something that cos alpha plus beta is cos alpha. Why not? That is additive distributive law. Why can't it follow? So this thing ये होता क्यों नहीं है? Somebody asked me. Beautiful. Let me make it sure that why these things are not like you wrote. Let's take a rectangle, name it like the little girl did, A, B and C, D, yes. And she told me to use a rectangle and try to prove why not sine alpha plus beta will not be equal to sine alpha plus sine beta. Cos alpha plus beta cannot be written as cos alpha plus cos beta. So I'm doing one thing here. Draw a perpendicular right angle triangle and inscribe a triangle, name it D, name it E, and inscribe a triangle, right angle triangle. A right angle triangle, DE, DEF. So let's write it E and name this corner as this point as F. And this point as E. It will be fine. Yeah. It will be. And make this angle, this is a right angle triangle. DE, DFE, or read it in anti-clockwise manner. Read it EFT. Okay. Now take this angle equal to beta. This angle. And this angle is alpha. You can see many things here. If this angle is alpha, this angle is 90 degrees, so this angle is 90 degrees. So this angle is 90 minus. And you know here, this angle is 90 minus alpha, this angle is 90 degrees. So together they become 180 minus alpha. So this angle should be alpha. Because all of the angle will be equal to 180 degrees. And you can see this angle is beta, this angle is 90 degrees. So this angle is 90 minus beta. Also, this angle is 90 degrees, so this angle will be 90 minus. I think you are following me. So, can you guess what will be this angle? The whole day together form 180 degree minus alpha plus beta. The whole angle should be equal to 180 degree. So this is nothing but alpha plus beta. Add all of them. And you will get your volatility. So this angle will be alpha plus beta. Now use all the triangles, all the right angle triangles, and write something like minus sine beta from here. From what triangle? DFE. DFE. Also, you can do one more thing. Just take, it will solve lots of your problems. If you can do it, let DE is equal to unity, 1 unit. Yes, I'm going to write it. DE is 1 unit. And now, find your sine beta. This angle is there, this angle is 90 degree, this is perpendicular. So, FE is confusing me. Right, let this E and write this as F. Seems good, but I have to change one more thing. Here, DF is unity now. So, sine beta becomes EF. EF upon hypotenuse is DF. DF is 1. We'll not write DF again and again. This is just one more time. This is the last time I'm not writing. DF equals 1. So, EF is equal to sine beta. Now find your cos beta, nothing else. Cos beta. And cos beta is base upon hypotenuse. That is ED upon 1. I made this hypotenuse as unity. ED, or better like it, write it D. So cos beta is D. Okay. Find sine alpha. You have to find anything. Using triangle, this time triangle DAE. Triangle DAE. Find sine alpha and cos alpha. Sine alpha is EA, perpendicular upon hypotenuse, that is DE. AE upon DE. Just calculate it carefully, sine alpha. AE upon DE, and D you can see here, cos beta. That means you got AE equals D, and D is cos beta. A equals cos beta sine alpha. That's your A. Now find cos alpha. And if you find cos alpha here, base, that is AD, upon hypotenuse, that is D. That means we got AD equals D is cos beta. So AD becomes cos alpha, cos beta. This is our finding. Not this. Okay. Go in this triangle also. In triangle what? Triangle EBF. EBF. Yes. we are going to make our calculation for this triangle. Let's find again cos alpha. Cos alpha. So I should have found out cos beta first. Later find cos alpha. Cos alpha is EB upon EF. EB upon EF. Cos alpha. We have EF. Here, EF is equal to sine beta. So, our next finding is that EB equals EF, that is sine beta cos alpha. And let me find one more thing. What is sine alpha in this triangle? So, I'm going to find sine alpha. Sine alpha is perpendicular upon hypotenuse BF by EF. Oh. So sine alpha is BF upon EF. EF. Sine alpha is BF upon EF. That's right. So EF we have that is equal to sine beta. So we are reaching to our next finding that EF is equal to sine beta sine alpha. BF is equal to sine beta sine alpha. You got this one. Now find one more, because one more triangle is left. Do one more. Just use this triangle, the triangle DCF. Triangle DCF. Yeah, now use this triangle. What is ahead? The angle is alpha plus beta. So find sine alpha plus beta. And it will be perpendicular, that is DC or CD. CD divided by hypotenuse DF, that is already equal to EB. So I'm stopping this video for a second because power is getting out. And so I have to connect my computer to the power source. And welcome back again. So sine alpha plus beta is talking about will be CD upon DF. So CD is simulation. Welcome to our next finding. CD equals sine alpha plus beta. Fine. Now find cos alpha plus beta. And cos alpha plus beta is base, that is FC or CF upon DF. DF is equal to 1. So CF or FC will be cos alpha plus beta. And we have a whole lot of information or a lot of findings at our screen. It says, what does it say? What does it say? It says, let me do something. It says something. It says me Let's find cos alpha plus Fc. Fc equal to cos alpha plus beta itself. And Fc is equal to AB. Can you see AB? Fc. Fc is not, sorry. Fc cos alpha plus beta Fc. That was right. Cos alpha plus beta is Fc. That is right. But this Fc is this side, BC. We don't have BC, but we have AD. AD. AD is equal to BC. You can see here. This AD is equal to BC. Yes. And BC is BF plus FC. So let me write thanks. Let me write something. I want to just remove it. And I can write AD equals BC. Let me solve it. AD is equal to BC. Here you can see AD is equal to BC. And BC is equal to BF plus FC. BC equal to BF plus FC. And I have a value AD. AD is cos alpha cos beta. Right? AD equals cos alpha cos beta. And BF, where is BF? BF is sin alpha sin beta. And FC is cos alpha plus beta. So what I get from here, that cos alpha plus beta is not equal to cos alpha plus cos beta. Rather, cos alpha plus cos beta is equal to cos alpha cos beta minus sin alpha sin beta. I think I have proven the fact, right? So, can we find sin alpha plus beta? Yes, we can. Sin alpha plus beta is equal to CD. CD is distance. CD is here. But CD is equal to AB. So let me write somewhere. CD is equal to AB. Oh, that's right. And AB is equal to A plus EB. So I would like to write here CD, that is equal to sin alpha plus beta equal to AB, and AB is equal to AE plus EB. Am I right? Yeah. See this length AB. Sorry. CD. CD is equal to AB, and AB is A plus CD. A plus CD. So I can write here CD equals sin alpha plus beta. And I will have to find this AE. Where is AE? AE is here. This is cos sin alpha cos beta AE and EB. Where is EB? EB is cos alpha sin beta. AEG is sin alpha cos beta and EB is cos alpha sin. So we have another information now. Sin alpha plus beta is sin alpha cos beta plus cos alpha sin beta. And we got the result. Two digits. These are called sum rules. I don't know what kind of something like this. So you can see you have sin alpha plus beta and cos. Now you can also find tan alpha plus beta. Not that big, but I can do things. It will be sin alpha plus beta upon cos alpha plus beta. Do next, sin alpha plus beta is sin alpha cos beta plus cos alpha sin beta divided upon cos alpha plus beta means cos alpha cos beta minus sin alpha sin. You will tell me that this is weak. I don't like this. Me too. So let's do one thing. Divide numerator and denominator both by cos alpha cos beta. Cos alpha cos beta. So if we divide the first term of numerator by cos alpha cos beta, we will have tan alpha. Cos beta will cancel out and sin alpha by cos alpha becomes tan alpha. And we do it here again. So in this case, if we divide by cos alpha cos beta, cos alpha gets cancelled out. And we get sin beta by cos beta, that is tan beta. And we can get here 1 minus sin alpha upon cos alpha is tan alpha. And sin beta by cos beta is tan. This becomes a bit smaller. That means tan alpha plus beta is again. And you can do much more. Like if you want, you can use sin alpha plus beta to find the values of sin 90, cos alpha plus beta to find the values of cos 90, tan 90, and you can find the rest of them. You can do one more thing. Let's put alpha plus beta equals theta. Both alpha plus beta. And write complete this formula. This formula is discovered that sin alpha cos beta cos alpha sin beta. And what happens if you put alpha equals beta equals theta? The left hand side becomes sin alpha. The right hand side will be simply 2 sin theta multiplied by cos theta. Alpha and beta both becomes sequential. You can use it in many ways. What happens to cos alpha plus beta? We do the same thing with Just wrote down the formula of this. And if alpha equals beta equals theta, beta cos 2 theta equals cos square alpha minus sin square alpha. I know. You also know cos square alpha plus sin square alpha equals 1. That means cos square alpha equals 1 minus sin square alpha, sin square alpha equals 1 minus cos square alpha. Sorry, cos square theta minus sin square theta. That's right, that's true. And you can make many manipulations if you want to. And the same you can do with tan 2 theta, you can also find tan 2 theta. And there are many more things you can do. Let's do one more thing. Whatever we did till now, we use our right and negative hand. The Pythagoras. Use sine theta, cos theta, trigonometrical basis, basic information of trigonometrical basis. Embedded with it. Now use some coordinate geometry, but let me invite circle for you. Circle. Circle. Round circle. So, now cancel. Where is the picture diagram? Oh, what happened? The symbol is missing. But let me draw a circle. I can draw a circle. It's not that important. Draw again and draw a circle. Well, this is the origin. Oh. I'll just draw an x-axis, y-axis. This is a center basically. Here is the center of the circle. Origin at the center of the circle. There are 4 quadrants. First quadrant, x and y coordinates are positive. Second quadrant, x coordinate negative, y coordinate positive. Third quadrant, both negative. Fourth quadrant, x positive, y negative. Let's draw. Let's make it a circle of unit radius. So this is a unit circle. Unit circle. That is the radius of the circle is unity, 1 unit. Let's take a point here. So that OA length will be equal to 1. OA length is equal to 1. And let make this angle theta. Make this angle theta. OA makes an angle theta with x-axis. Now what happens if I draw a point B here and OB is also equal to 1 unit. But I should have taken this angle as theta. Let me tell you something. This theta angle has been made by rotating this radius in anti-clockwise sense. And if the same radius is rotated in clockwise sense, this angle theta. Does it make any difference? If we draw an angle, we rotate something, say radius of a circle, then sense of rotation does matter in trigonometry. If you rotate it counterclockwise, for the sake of people, that you have rotated a line, an arrow in anti-clockwise sense by 30 degrees, say by 30 degrees, then you write this angle simply as plus 30 degree or 30 degree. People will know that this angle has been made by rotating an arrow in anti-clockwise manner. If you rotate it clockwise, simply write like we do in softwares. Simply write minus 30 degree, and people will understand that you have rotated an arrow in clockwise. So, make this a habit. Make this an habit. This is a good habit. And now I want you to write the coordinates of point A. This length is x coordinate, that is OA cos theta, and since OA is equal to unity, that means x coordinate of point will be cos theta, and this y coordinate will simply become sin theta. So, let's take an angle here. This angle. And try to write the coordinates of point A dash here. Again, this length is what can I say? OA dash cos theta. So the x coordinate of A dash will be minus cos theta. X coordinate in this quadrant is written with a minus sign, and y coordinate will be sin theta. And let's measure this angle from here. You just what you would like to call this angle. Call this angle. Since the whole angle here is 180 degree. So you come here to here by 180 degree in anti-clockwise direction and then rotate your arrow in clockwise direction, this number. 180 degree, then rotate 180 degree counterclockwise, theta angle clockwise. So, this angle will be 180 degree minus theta. And if you take this angle, then you should write the coordinates of point A dash as cos 180 minus theta, point A dash as cos 180 minus theta, and sin 180 minus theta. And just compare these two things. Since both are x and y coordinates of point A dash, you will get something. You will get that you are writing cos 180 degree minus theta equals minus cos theta. And sin 180 degree minus theta equals sine theta. So that means what? This is a new result. And you will get like this: cos 180 degree minus theta is cos theta, and sin 180 degree minus theta is. Do some more experiment. Oh, do some more experiments. But I said, so that wrong. Everything again. Let me do it. Yeah. A circle, unit circle. X-axis, y-axis, here is the origin. And here is a point A, having coordinates cos theta and sin theta. That means this angle is equal to theta. Right? Now, draw a line here. Or you can draw a line here as well. Let's call it point B. And make this angle equal to theta. Then you will write the coordinates of point B, x and y coordinates. This will be OB sin theta. This length is OB sin theta. So its coordinate is x coordinate is minus sin theta, and this length is cos theta. So its x coordinate will be cos theta. And draw an angle from here to here. And you move the angle 90 degrees from here to here in anti-clockwise then, and again you continued and moved an angle theta in the same sense, that is in counterclockwise sense. That means this angle you would like to write sin 90 plus theta. So from this 90 plus theta, if you consider this 90 plus theta, you could have written the coordinate of B as cos 90 plus theta and sin 90 plus theta. And if you compare the coordinates of B by writing in two different manners, you must agree that cos 90 plus theta is equal to minus sin theta, and sin 90 plus theta will be equal to cos theta. Compare this. Take another example. Take another example. Take this point at C and make this angle theta. So that this length is UDT and this length is cos theta, so its coordinate will become cos theta. It is in fourth quadrant, so its x coordinate will be positive cos theta, and y coordinate will be minus sin theta. Now now try to find, not try to find, it is given this time. Sorry. You know, by considering an angle from coming from here and reaching here. You travel clockwise. So if you write things in this manner, its coordinates should have been cos minus theta and sine minus theta. And I got one more thing here, that cos minus theta is cos theta and sine minus theta is minus sine. If you learn the whole thing, you don't need to remember any formula, and you will be able to do these things whenever you want. You don't need to remember anything. Just complete your table. Like try to find what is the value of cos 90 minus theta, sine 90 minus theta, sine 90 plus theta, cos 90 plus theta, cos 180 minus theta, cos 180 plus theta, sine 180 minus theta, sine 180 plus theta, and like this. Just try to find it. And now we have another formula, like we have sine alpha plus theta, sine alpha cos theta plus cos alpha sine theta. We can find sine alpha minus theta simply by replacing beta by minus beta. Like this. This alpha minus beta is, you can see it properly. You can write it here as sine alpha plus, that is sine alpha. So replace every beta by minus beta. Sine alpha cos minus beta. Cos alpha sine minus. And you have your result. This will be sine alpha cos minus beta is cos beta plus, it will eventually change, cos alpha multiplied by minus sine minus beta is minus sine beta. So we need to change here. And it will become like this. Go get your cos alpha minus beta, tan alpha minus beta. I'm waiting. Do these things. And must do the exercise. I given earlier. Thank you very much for now.